Hello, in this video, let's talk about how to find area of any regular polygon. So do you remember what polygon it was? From the word polygon, the gon part means angle and poly means many. So polygon is a shape or figure with many angles. So starting from triangle with the three angles, to square or rectangle, right? To pentagon, hexagon, heptagon, octagon. We can just keep increasing the number of angles until like, I don't know, 30 gon, 50 gon, 127 gon, right? We can keep increasing it. And basically polygon is a shape with however many angles, right? So I have an example of a polygon here. It's a square. It has four angles, so it's type of polygon, right? Now we're only going to talk about regular polygon today. Now what does it mean to be regular, right? Well, regular means you have same degree angles all over, right? And same side length all over. So rectangle is not a regular polygon because while all the angles are 90 degree, the side length are different, right? Out of triangle, only the equilateral, equiangular triangles are regular polygon, right? Regular triangle. If it's a pentagon, all five side length have to be the same, and all five angles have to be the same. So that's the regular polygon we talk about. Now, irregular, some different shape of polygon, that's for some other time. Okay, so now let's move into finding area of any regular polygon. So for this, let's first derive the formula for it. Okay. So for example, I have a square over here. Now the center point here I have drawn. This is the center of this square, right? And if it's a regular polygon, you have a center part, right? Center of a regular polygon. When you connect the center to each vertex, right? The length is all the same. Okay, so here, this is square and we have a center. That means this, all four lengths, the connecting lines, segments are same. And that works for the pentagon as well. I'm really horrible at drawing a regular pentagon, but just suppose it's a regular pentagon, okay? Suppose it's a regular pentagon, that's horrible. If it's a center, and if that is a regular pentagon, when you connect to each vertex, they should be all same, okay? So that's how the regular polygon works, okay? Center to each vertex, same length, okay? And I have then, for this square, once we connect the center to the vertex, it created four same triangle, right? Four same triangle. You can see that they are isosceles triangle, and we created four same triangle. And if I were to draw a segment from the center to the side at a 90-degree angle, right? That is the height of this one triangle right here, right? This segment is called apothem. Okay, apothem. I always have a hard time pronouncing that, apothem, right? That is what is called the height of this triangle. And this apothem, if we were to draw to all four triangles, that makes what? Eight same triangles here, right? 8 same triangles. So we divided the square into 8 triangles, okay? Now, if I call the side of a square S, right? What is the perimeter of the square? Well, that would be, since there are 4 S's, right? 4 times S, right? And yeah, let's go with that first. If I have pentagon with the 5 sides, right? Then for pentagon, it'll be 5S, right? If I have the decagon with the 12 sides, well, the perimeter would be 12S, right? So, do you see something here? For square, 4. For pentagon, 5. For decagon, 12. If you have 17 gon, there'll be 17S. So basically, what is the perimeter of n-gon, right? We don't know how many sides or angles. What would be the perimeter for that? Well, that would be ns, right? Whatever the side that we have, and the number of sides is the s, right? And this works for regular polygon only because we know that regular polygon has all the same side length, right? So for the n-gon, parameter is ns. Okay? Now, let's look at this triangle right here. This triangle. Okay? What would be the area of this triangle? Well, we know triangle area is base times height divided by 2, right? Or 1/2 times bs, right? Well, instead of bh, sorry. So instead of b, we have s, right? So we write 1/2. Instead of b, we have s. And then apothem, right? That is a height. So we can write that as a, right? If you write that as alphabetic order, yeah, that's what we have. Area of this triangle is 1/2 times a times s, right? Then what is the area of this square right here? Well, you see that there are 4 of these triangles, right? 4 of these triangles. So we multiply 4 times 1/2 as, right? 4 of them. Now, do you notice here? This is a square with 4 sides, right? 4 angles. So we multiply by 4 here. But if you were to have a pentagon, regular pentagon, right? And if you were to draw a bottom there, how many triangles are there? 1, 2, 3, 4, 5. Pentagon has 5 triangles. If we have a hexagon, right? How many triangles will we create? 1, 2, 3, 4, 5, 6. 6 triangles. Oops, here. So you can see that depending on what polygon is, how many side or angles, that is how much you multiply by. That is how many triangles you create. So what would be then? What would it be? The area for n-gon, right? N-gon area is equal to n times 1/2 as. If you were to write that alphabetical order, that would be a and s, right? That would be the area for any n-gon. So if you know the side length, apothem, and what kind of polygon it is, then you can find the area. Now notice this. We know n-gon perimeter is ns. We know n-gon area is 1/2 ans. Do you see how we can substitute ns with a p? Ns with a p? So we could rewrite our formula into a area of n-gon is 1/2 times the apothem a, and then perimeter p. And that is how we can derive the area formula for any regular polygon. Okay, so let's do some problem solving. Okay, problem solving knowing this. Okay, let's say we have, suppose we have a regular hexagon with side equal to 10. Let's do the easy number. Yeah, regular hexagon with the side 10 centimeter. Okay, what is the area? Well, here, just follow me through this. Okay, so if I were to draw a regular hexagon, I'm gonna try my best. Okay, well, I don't think that's that bad. Yeah. Okay, if you were to draw a regular hexagon, just imagine this is a regular hexagon. If you were to draw a segment from center to each vertex, we created 6 triangles, right? And then if we drew a bottom like that, 90 degree right there. Yeah, we know each side is 10 centimeter. This is 10, that's 10, 10, 10. We know they are equal length. So this triangle right here on the bottom that we're looking at is an isosceles triangle. And for isosceles triangle, if you were to draw this segment 90 degrees to the side, that would create this and this same as well. 2 congruent triangles. So one of them is what? 5 centimeter. 5 centimeter, right? Okay, let's take a look at this triangle over here. This is 5, right? And what would be this angle? Now to find this, you have to think about this. We know that if we make a full circle, that is a 360 degrees, right? 360 degrees. 360 degrees. And how many triangles did we divide this 360 degree into? 1, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total 12. How did it happen? There are 6 triangles, right? And then each 6 triangle we divide into half of that, right? By drawing apothem. That will give us 12 same triangles. So you divide by 12. That gives us 30 right there, right? So that means this degree right here is 30 degree, okay? Now we want to know the apothem right here, how long that is, right? Well, that is this one right here. Do you see something here? We know the angle, we know the one side, and then we want to find the other one. You got it. This is when you use SOHCAHTOA, okay? Well, this is actually a special 30, 60, 90 triangle, so if you remember that, you don't have to use a SOHCAHTOA. But but you could use SOHCAHTOA for anything, so let's try that, okay? So we're dealing with opposite and adjacent, yeah? We know the angle. So opposite and adjacent is what? SOHCAHTOA with a tangent, right? So we know tangent of 30 degrees is equal to 5 over x. Now, how do you find x? We can use a cross multiplication like that. We have x tangent of 30 degrees is equal to 5. Divide both of them by tangent of 30, right? Tangent of 30. This cancel out. X is equal to 5 over tangent of 30 degrees. Now for this, you have to use a calculator, right? You have to use a calculator. So let me pull out my calculator over here. Yeah, there, and then let me clear, okay? So if I were to use a calculator to do that, x is equal to 5 divided by tangent of 30 degrees, I go 5 divided by tangent of 30 degrees. And I think it's in the degree setting. Yep, that's good. All right, 5 divided by tangent of 30 degrees. And that comes out to be 8.66. So I round to the nearest tenth. That's approximately 8.7, okay, centimeter. So we now know that x is about 8.7 centimeter. Now we simply plug into the formula. We know that area is right here, 1/2 times apothem times p. Well then, area is, for this hexagon, 1/2 times what's apothem? That is 8.7. So 8.7 times what is the perimeter? Well, each one was 10. There are total 6 sides, so the perimeter is 60, right? Okay. Well, 60 times 1/2 is 30, so that is 30 times 8.7. Yeah, and then if I were to do that again with a calculator there, yeah, 30 times 8.7 comes out to be 261. So the area of this hexagon is 261 centimeter square. And that is our answer for this hexagon. Okay, so this is how we know the area formula for any regular polygon. And using that, and using SOHCAHTOA, find the area of any regular polygon when you're given one side length. Okay, for this angle, we can, if it's a nonagon or you know, whatever, the decagon and so on and so forth, just think about what you need to divide 360 degree by to find the angle. Use a tangent to find the apothem, and with that you can find the area. Okay, so I hope that this video helps, and good luck. Bye.